Hello students. Today's topic of a discussion is the total internal reflection. Let us say there is a pond and this is the bed of the pond of water, let us say, and here a pebble is lying, and from the upper side, that is from air, you are seeing that a pebble. Now see how we see this pebble. Imagine that this water is a crystal clear. That means what the pebble, all the pebbles, whatever is lying in the bed, it's very clearly visible. Assume that the water is crystal clear. Now, how we see something, anything, not only the pond, anything, how we see light falls on the object. Let's say this duster is here. Light falls on this, that gets reflected and falls on the retina of my eye, inverted image, and you know the entire story. That means whenever light gets reflected from one object, we are able to visualize it. Similarly, from this object, let us call it O, from this infinite light rays are emanating in all the directions, infinite directions. However, few rays we are taking for our analysis purpose. The light ray which is perpendicular to the surface of the water will go just like this. However, the light ray which is making some angle. Now see, at the point of incidence, if we draw a perpendicular, this light ray will be deviated away from the normal, yes or no, because this is water and this side is air. Water is denser than air. Now light is passing from denser medium to rarer medium. That's why it will be going away. Yes or no? Now if I am taking a light ray which is having angle of incidence more, we are increasing the angle of incidence. So the bending which will be away from the normal will be farther, right? So if we go on like this, for a particular angle of incidence, the refracted ray will become parallel to the surface of the water. Fine. Now I am just showing in two dimensions here in the board. This side, that side, this side. You imagine in a 3D structure, so there will be a cone of lines, right, of a certain radius. So always till then it's okay. But after that, what happens? Now this angle for which angle of incidence, the refracted ray makes 90 degree with the normal, or that angle of incidence for which the refracted ray becomes parallel to the surface of water is called critical angle. I become equal to C, symbol is C, and it's called critical angle. Why it is called critical angle? Because any ray, a little more than that also, if you will show any ray after critical angle, that means the angle of incidence becomes more than critical angle now. Then what happens? Obeying the law of reflection, which says angle of incidence will be equal to angle of reflection. So making that the angle will be reflected back to the same medium. Okay. Now say till here it was refraction, right? Even till critical angle, the refraction happened and the refracted ray became parallel to the surface of water. However, if the angle of incidence becomes greater than critical angle, then the light ray, the incident ray, is reflected back into the same medium, obeying the laws of reflection. This phenomenon of a light, where the light ray turns back into the same medium, is called total internal reflection. So the phenomenon of light of reflecting back into the same denser medium when angle of incidence is more than critical angle is called total internal reflection. So what are the conditions for total internal reflection? There are two conditions. Light must travel from denser medium to rarer medium. Then only total internal reflection will occur. And second condition is angle of incidence must be greater than critical angle. So when these two conditions are satisfied, total internal reflection, this phenomenon of a light takes place. Now let us understand it a little mathematically. See, the angle, when the angle of incidence becomes a critical angle, at that particular instant we are considering the triangle where angle of incidence is equal to critical angle. Let us call this point is A and this point B, the point of incidence where exactly the light, refracted light, becomes parallel to the surface. Okay, now in this triangle you see this is critical angle. So don't you think that this angle will be the same angle, critical angle Y? Alternate angles. So this is C, yes or no? Now apply the Snell's law at point B. Mu is equal to sine I upon sine R. Sine I upon sine R. Now I is the critical angle here. So sine C upon R is 90 degree here. Sine 90 degree. Yes or no? Now sine 90 degree is equal to 1. So sine C upon 1. But now this mu is what? Refractive index of the second medium with respect to the first medium. Now here from here, when we are considering the light is moving, our second medium became air and first medium is water. So this became refractive index of air with respect to water. Yes or no? Understand this. Now I am erasing the definition to make some space. Now from here I am writing, see, refractive index of air with respect to water is sine C divided by 1. So principle of reversibility, you remember, refractive index of water with respect to air will be the reverse of this, right? Implies that refractive index of water with respect to air is equal to 1 divided by refractive index of air with respect to water, and 1 divided by, this is sine C, yes or no? And refractive index of water with respect to air is generally called refractive index. What is the refractive index of the denser medium? We are standing in the air and we are interested to know the refractive index of water. So refractive, it is called, therefore mu is equal to 1 by sine C, where mu is the refractive index of the denser medium. Is it clear to everybody? Now let us take up this problem, a question, a simple question which says calculate the minimum angle of incidence so that a ray traveling from glass, refractive index of a glass is given to be 3 by 2, to water, refractive index of water is given to be 4 by 3, does not emerge out of water. Now see, isn't this a question of total internal reflection? Light is coming out of what ray? Traveling from glass. From glass light is traveling and it is coming out to water. Now refractive index of glass is given to be 3 by 2, refractive index of water is given to be 4 by 3. Within these two, which is bigger? Take 6 LCM 2, 3, this is 9, 2, 3, this is 9, and 3 2s, this is 8. So refractive index of a glass is bigger than water, right? What are the two conditions for total internal reflection? You remember, light has to travel from denser medium to rarer medium, so that is satisfied. And also it is saying calculate the minimum angle of incidence so that it doesn't come out. So you can imagine this is glass and above it's water. Now from glass ray, if a light ray is coming out, what is the minimum angle of incidence so that it doesn't come out of water? That's what it is asking. A ray traveling from glass to water does not emerge out of water. That means what is the minimum angle for which total internal reflection takes place. That's the question. Or indirectly it's asking what is the critical angle, as simple as that, right? Now see, refractive index of a glass is more than refractive index of a water. So what is the refractive index of the denser medium? Refractive index of the denser medium, mu, is equal to mu glass with respect to water. Mu glass with respect to water. This is nothing but refractive index of glass divided by refractive index of refractive index of glass divided by refractive index of water. And what is the refractive index of glass? 3 by 2 divided by 4 by 3. That's multiplied by 3 by 4, which is equal to 9 by 8. Now see, refractive index is equal to mu is equal to 1 by sin c. We know this formula, right? I have erased now. So let's make some drama for this simple question also. Mu is equal to 9 by 8, mu is equal to 1 by sin c. From these two, what we can conclude? Therefore, 1 by sin c is equal to 9 by 8, or sin c is equal to 8 by 9. Therefore, c is equal to sin inverse 8 by 9. So if inverse table is available, you can read that sin inverse 8 by 9 is equal to 62.7 degrees. Clear? Now let us take up a nice question which asks, there is a fish at a depth h in a clear and calm water. Prove that the surface of water appears like a mirror to the fish except a circular region of a radius r, which is equal to h upon root under mu square minus 1, where mu is the refractive index of water. Let us see what it says. Let us say this is the surface of water. Let us say the fish is swimming here, okay, and the depth of the fish is given to be, there's a fish swimming at a depth h. It's given, depth is given to be h, okay. Clear, calm water. This water is clear and calm. Okay. Now prove that the surface of water appears like the surface of water to whom? To the fish. You imagine yourself at the place of the fish. If you look up, the entire surface of the water surface looks like a huge mirror, except a circular region of a radius something is given. Now let us conceptually understand what happens if light ray from the eye of the fish, if you are seeing, this light ray will go undeviated. However, if we take one light ray like this, it will be deviated, and at the time of when the angle of incidence becomes equal to critical angle, you know this now, right? The refracted ray will become parallel to the surface. Now just parallel to the surface, when it becomes, it's not at one place only. You imagine it in a 3 dimension now. So this side also, this side also, this side also, in a board in 2 dimension. I am showing only 2 things where this is a total internal reflection. Just after this, total internal reflection will take place. And if a reflection is taking place, that's a mirror. After that, it's a mirror. After this also, this is a mirror. The surface of water is a mirror for the fish. Now in 3D, if you are thinking, there will be a cone like this, right? In all the directions, after a particular length, it becomes one. After a particular radius, let us call, it becomes a mirror. So there will be a circular region. After a particular radius, this side also R, in every side it's a R, in all the sides. After that, it appears as a mirror because internal reflection is taking place after that. But just before that, the sky is visible to the fish. That means the huge water surface will be looking like a huge mirror, except a circular region of certain radius. And we are now going to prove that the radius is equal to h upon root under mu square minus 1, where mu is equal to refractive index of water. Now see, in this triangle, instead of saying this, let's give some names. Let us call this O, this is A, and this point is B. In OAB, right angle triangle, this angle is C. critical angle, yes or no? See, this is critical angle C, then this angle will be also C because alternate angles. Now this is a symmetric, right? So if this is C, this also will be C only. Now in triangle OAB, sin C is equal to how much? Sin C is equal to P by H. Now see, this OB is the depth is given to be H in the question. So OA will be equal to root under R square plus H square. Yes or no? So sin C is equal to R divided by root under R square plus H square. But we have already derived that mu is equal to 1 divided by sin C is equal to, sin C is equal to this much, so 1 divided by sin C, that is root under R square plus H square divided by R. So mu is equal to root under R square plus H square divided by R, implies that multiply this mu R is equal to root under R square plus H square. Now square both the sides, implies that mu square R square is equal to R square plus H square, implies that bring this R square to the left. Is it visible? Bring this R square to the left. So R square if you take common, it becomes mu square minus 1, implies that R square if you take common, mu square minus 1 is equal to H square. Am I correct? So from here I am writing, implies that R square is equal to this H square divided by mu square minus 1. Now take root both sides, therefore R is equal to root under left hand side is equal to root under right hand side, H divided by root under mu square minus 1. So the fish, the surface of water will appear like a huge mirror except a circular region of a radius R, which is given by H divided by root under mu square minus 1, where mu is the refractive index of water. That's what was required to be proved, right? So this question is solved. Now the exactly same question may appear different. For example, suppose the depth is 10 centimeter is given in a question. If the depth is equal to 10 centimeter and refractive index is equal to 1.532, let us say circular, what is the radius of the circular region which is cut from the huge mirror from the point of view of the fish? Like this it may be asked, or it may be asked if the fish is visible through a circular region of a radius at 10 centimeter and the refractive index is 1.532, then at what depth the fish is swimming? This way also it may ask. That means of R, H, mu, three unknowns are there in this equation, right? Here R may be asked, H and mu may be given, R and mu may be given, depth may be asked, or depth and radius may be given. What is the refractive index of this material? That also may be required to be calculated. And altogether the same question may be asked. Suppose there is a tank of water. At the bottom there is one electric bulb which is glowing. From the top when you see, and if this experiment is carried in a dark room, from the top it is seen that a very illuminated circle of a radius R can be seen from the top. Then what is the depth of the tank? It may be asked. So indirectly that is the same concept as this, you have understood, right?
So we had just discussed the fish tank problem from total internal reflection on board, and if you have understood already, you can skip this animation. Let us say the fish is under a depth h from the surface of water. Okay, let us say that light ray is passing directly, it goes undeviated. However, if one light ray you are imagining from the fish eye, which goes a little tilted, it goes away from the normal after refraction, and let us say this continuous, and at a particular angle C, that is when the angle of incidence becomes equal to the critical angle, the refracted ray becomes parallel to the surface. However, just after this ray where the incident angle becomes equal to the critical angle, after that all the rays are just reflected back to the same denser medium. That's why to the fish it will appear as a huge mirror, which will appear means which will what will appear, the screen, the surface of water will appear like a huge mirror to the fish. So there will be a circular region which will be through which circular region the sky will be visible to the fish. That means the entire surface of water to the fish will appear like a huge mirror except a circular region of radius small r. This is conceptually clear, and we are going to calculate the radius. Now you can see this right angle triangle where the radius is r and the depth is given to be h, and this is naturally root under h square plus r square, because applying Pythagoras theorem. Now let's give some names: A, B, C. Now here we already know that mu is equal to 1 upon sine C, where C is the critical angle and mu is the refractive index of the water in which the fish is swimming, or refractive index of the denser medium. We know that, right? So since mu is equal to 1 by sine C, and from the right angle triangle we can clearly see that the sine C is equal to r divided by root under h square plus r square. We can square both the sides to find this, which ultimately gives rise to r is equal to h divided by root under mu square minus 1. This we get when we take a root under on both the left hand side and the right hand side. Hope this is crystal clear.